So today we will talk about triangle geometry and its relationship with pentagon geometry. Have you ever wondered why we do not talk about pentagons separately? We talk about triangles and then there is a separate chapter on circle geometry, but we do not have a separate chapter on pentagon geometry, let's say. Why is that? Well, one reason is that when you have a pentagon, you can actually split it into a bunch of triangles. This process is sometimes known as triangulation. So in a way, if you know triangle geometry, then you automatically know pentagon geometry using this method of triangulation. Today, we will talk about one properties of triangles that also works for some pentagons, and it's related to angle bisectors. So welcome to the Math Olympiad Can Be Fun series on crayons. This video is sponsored by Cheenta.com. If you want to know about exciting and fun programs on mathematics, check the link in the description. Let's get started. So first, let me talk about a triangle ABC. So ABC is a triangle. Any triangle, it could be scalene, it could be isosceles, it could be equilateral. And we have drawn three angle bisectors of this particular triangle. So this is one, this is the other one, and this is the other one. Now there is something weird that's happening here, something really weird, and that is the three lines are passing through the same point. If you have seen some triangle geometry, you know this point is known as incenter. Of course, three lines do not need to pass through a same point. That's not always true. But for angle bisectors, this is true. So here's a little challenge. Can you prove this? Try this in the comment section. Try to show that if we draw the angle bisectors of a triangle, they will pass through a single point. Now we want to know whether something like this happens also for pentagons. So let's move on to pentagons now. Now we don't want to talk about all pentagons. We are interested in the regular pentagons. Okay? So what is a regular pentagon? Well, it has three properties. First of all, it's a pentagon, so it has 5 sides. All sides are equal and all angles are equal. If all three of these properties are satisfied, then this pentagon is known as a regular pentagon. Okay, so I will have a side question for you now. We will come back to the regular pentagon, but first let's look at this side challenge question. So if sides of a particular polygon are equal, does that automatically mean that angles are equal? Well, that's true for 60-degree triangles, that is equilateral triangles. If three sides of a triangle are equal, then automatically the three angles will be equal. But is it true in general? Let's say, is it true for quadrilaterals? Is it true for pentagons? If sides are equal, does it automatically mean angles will also be equal? You can try this and you can put an answer in the comment section. Now let's move on to the main problem. So here is the big question. Suppose we have a regular pentagon. That is, all sides are equal and all angles are equal. That's given. Will all the angle bisectors of this regular pentagon meet at one point? Remember, that's true for any triangle. In any triangle, the angle bisectors meet at a single point. My question is that true for angle bisectors in a regular pentagon? Regular pentagon. So why don't you pause the video here and give it a try yourself. Okay, again I have a side question for you. This is a challenge problem. If all angles of a regular pentagon, of course they are given to be equal, all angles are equal, then each angle is 108 degrees. Why is that? Can all of you give it a try? If all angles are equal, which is true in a regular pentagon, then the measure of each of those angles, this sort of angles, those are 108 degree. I need a proof of that. If you can, put that in the comment. Okay, now we are back in the main problem. So you want to show that all of the angle bisectors will pass through the same point. Indeed, it is true. So to do that, we will start with two angle bisectors. This is OA bisecting angle A. So this angle is 54 degree and this angle is 54 degree. Why? Because the total angle is 108 degree. It's a regular pentagon. All of these angles are 108 degree. Similarly, this angle is 108 degree. So this is 54 and this is 54. So OB and OA, they meet at the point O. What we want to show is that if we just join OC, I'll connect these 2 points O and C, then OC will bisect angle C. That's my claim. That is my claim. And we are going to show this by a congruence of triangles. It's quite simple. Try to show that triangle OAB and triangle OCB. So OAB is this triangle and OCB, maybe I can use a different color. OCB is this triangle. These two triangles are congruent. Why is that? Well, BC is equal to AB. It's a regular pentagon, so all sides are equal. OB is common. And notice that these two angles are 54 degree because after all, this is an angle bisector. So these two triangles are congruent by SAS rule of congruency. Now we are almost done. Since these two triangles are congruent, therefore these two angles are equal and both of them have to be 54 degree because this one is 54 degree. OA is given to be bisecting angle A, so this is 54 degree, which means this angle is 54 degree. Now that would automatically mean that this angle is 108 degree minus 54 degree, which is also 54 degree, showing that OC is bisecting angle C. Okay, so we are done because using the same strategy, you can show that OD and OE are the bisectors of angle D and angle E. Give it a try and try to formally prove this in the comment section. If you have more ideas and more interesting problems that you want us to solve, let us know. Visit cheenta.com for beautiful mathematical programs and more content like this. Thank you.